Hello everyone, my name is Musisi and I'm going to be taking you through Introduction to Neural Networks. So this is a continuation of the upskill data analysis courses that you've been doing, and today I'll be taking you through what neural networks are about and helping you understand how they've developed, their history, and how we use them today. So what are neural networks? Neural networks are one of the most famous and sexy parts of machine learning and data science. So if you've heard anything about data science, you probably heard about neural networks, and you most likely have been waiting for this point when you can start to play around with them and understand what they do. So the reason for this is because over the years they've had multiple uses and they've spurred advancements in machine learning. So areas of use include natural language processing, computer vision, you've heard of driverless cars, machine translation, which is what Google Translate does. And so all these have provided various ways that we can advance in terms of using machine learning. And it's because of this that they've become very hyped and there's been much interest in them. So what you can see here is an example of a neural network, and what it shows is there's an input, and then there's a hidden layer and the output. So the input is where generally the data that you have enters, and then in the hidden layer, which we'll talk about later, is just another layer of neurons, and then the output is where you receive the output of the hidden layer from the hidden layer and from the network in general. So first we'll talk about the history of the neural network. So what's the history? So neural networks have been around for a number of years, and the idea for this began initially in the 1940s and 1950s is when the idea really began. And the idea then was that computation should be based on how the brain works. And so the understanding is that the brain is one of the most complex learners and one of the most complex systems that we know about. And so the early attempts at artificial intelligence were trying to see how computation could be modeled in a way that mimics how the brain works. So with understanding of how the brain works, the idea was then to create computation that mimics how the brain is able to process information, and then we could create computational models from this. And then these models, or what you could call learners, the plan was for them to eventually surpass the abilities of the brain. And of course, as you all know, to this day this hasn't happened yet, but the plan is still to go ahead with artificial intelligence, particularly using neural networks, and this is what deep learning is basically about. So I'll take you through the timeline of how neural networks have evolved all the way from the 1940s up to today. Of course, we'll skip a number of different areas that are not very relevant. So the very first, I would say, step that took place is in 1943, two researchers, one a psychologist and a mathematician, Warren McCullough and Walter Pitts, they write a paper called A Logical Calculus of the Ideas Immanent in Nervous Activity. And here they're basically describing how the brain works and how electronic functions could be made to mimic how the brain works. And so the focus was on the idea of brain neurons being used or electrical circuits being used in place for brain neurons. And so this sort of spurred the interest in this idea over the next few years. And the next step was Donald Helb, who writes a book called The Organization of Behavior. And here he mentions further how neural pathways in the brain are strengthened as they're used more. And the idea is that this could be translated to how electronic networks and circuits are used, if used to mimic the brain, could easily be strengthened with more training and more learning. So the first successful attempts to develop any of these sort of networks was at IBM and MIT in the 1950s. And then eventually this led to the development of the perceptron. So a psychologist at Cornell University called Frank Rosenblatt in 1958 suggested a perceptron, which was based on the idea of a fly, the eye of a fly, and the systems it used to determine when to flee. To flee basically when it senses danger. So the perceptron idea is that it takes inputs and is able to produce output, and through a number of iterations is able to learn how the weights of the inputs would be. So an example here is shown of a perceptron, and you can see the different inputs, and which are from I1 to IN, and the weights are W1 to WN. So the weights correspond to each of the inputs, and then where you see the summation sign is what is the actual perceptron, and this is what receives and sums up the different signals or the different inputs. And so from that, this is then fed to this a threshold, which is basically like a step function. And so the output in this case was a binary output, which was either 0 or 1. And so if the output was if the sum from the summation function is beyond a given threshold, then the output is 1, and if it is below, the output is 0. And so this was the basic idea of a perceptron, and this was the very first beginning of the development of what we see as neural networks today. And so the idea with this was used a bit, but one of the main issues was that the perceptron could not learn how to separate classes which are not linearly separable. And I'll go into what linearly separable means in a short while. So this is a picture of the actual perceptron, and that was developed at Cornell, called the Mark I perceptron. So this is a hardware implementation, and of course you'll see it's a very large version of what even what a neural network is today, which you can run on your simple computer. So it was a hardware implementation that was able to perform the different functions over those different wires, and it was called the Mark I perceptron. So what is linear separability? So linear separability is basically, depending on the data that you have, if you have, let's say the simplest example is if you have two classes, like is shown here. So we see an example A, and then we see example B. And in example A, we would say these are linearly separable classes because if you look at the green circles and the blue circles, you can separate the two different classes using a single line. And that's what linear separability means. And so in B, then, we can see there is no single line that can separate the two classes. However, you could have you can separate the classes still, but not with a single straight line. And here we see there is a circle that is differentiating the two groups between the green circles and the blue circles. And so in machine learning, it's a very important idea to understand what kind of data you're trying to train on, if it's linearly separable or inseparable, because that determines the technique that you're going to use. So going back to the perceptron, the idea was that the perceptron was able to work with data that's like A, which is linearly separable, meaning a single line can separate it, and so it could learn and be able to distinguish between the two classes. But in the case of data like is in B, the perceptron would not be able to work with this. So going back to the timeline, moving on from here, in 1959, researchers Bernard Widrow and Marsh and Hoff from Stanford developed models called Adaline and later on Majaline. So Majaline, most importantly, was used to remove noise in phone lines, and importantly, this is still in commercial use today, all the way from 1959. So when this came out, around this period, there was what I'd call unwarranted hype about the potential of these networks, despite the limitations in computation at that time. And so this was all brought to a halt when Marvin Minsky, the founder of the MIT AI lab, published a book called Perceptrons. So in here is sort of squashed the hype around perceptrons because he mentioned that this could not be feasibly made into multi-layer networks, which is what would be required to create models that are linearly separable. So this went on until 1982 when John Hopfield presents the Hopfield net, and Japan again also found re-interest in neural networks with their 5th generation effort. And so from 1982 to 1986, researchers sort of rediscovered backpropagation, which is a technique that had already been there since the 1960s. And with backpropagation, this signified the return of neural networks. And the combination of backpropagation and gradient descent is sort of the secret sauce that led to neural networks, which are more like a combination of multiple perceptrons being able to be trained. Thank you.